limit 1. So it's as x approaches 2 pi from the right.
So limit as
X approaches 2 pi from the right.
yes.
Is x cotangent x.
Excellent. That's it?
Yeah.
Awesome. Okay, so we're looking at a trig function which is cotangent. I don't recommend you working with anything but the simplest possible functions. And cotangent is a function, a trig function, but I highly recommend write x cotangent x as x cosine x divided by sine x, or of course x cosine x over sine x. Why? Because I still believe that it's easier to think in terms of sine and cosine than in terms of cotangent. Okay, it's the same function. No changes whatsoever. So let's go to limit x approaches 2 pi from the right. And this is x cosine x over sine x. Let me refresh your memory. This is 0, pi over 2, pi, 3 pi over 2, 0 or 2 pi. Angles bigger than 2 pi, so after a complete rotation I get to 2 pi, and angles bigger than 2 pi have to be here. But bigger than 2 pi we really mean close by. Why, we don't mean here. We don't mean here, right? So it's close, approaches 2 pi from the right, with values or angles higher than 2 pi. So basically we're looking at the first quadrant. Can anyone tell us how much is cosine, what cosine x approaches, what will approach when x approaches 0 or approaches 2 pi? Same thing, 0, 2 pi are the same point. Very good. Thank you. 1, indeed. Do you all agree with 1? Yes? Do you need me to show any of this? You can always stop and say, I don't remember this, show me, and I'll take a minute and show you. Are we okay with 1? Okay, then. So this approaches 1, it's okay, it's friendly. This is no problem. This approaches 2 pi. When we know from the limit laws, when x approaches blah, 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 the limit of x will be that thing, 2 pi. But now I want to determine how much this approach.
0.
Yes. So the limit is 2 pi over 0. We know that there is no hope. None whatsoever. This limit will never exist. It's a number over 0. No one can change that. But the question is now, since we know that no hope means 3 different things, and we have to choose the right one, either infinity or negative infinity or DNE. So then the top is a positive number no matter what we do. Now I only need to determine whether sine approaches 0 from positive numbers or from negative numbers. That's the reason why I needed to identify the quadrant from the very beginning. So if you say that sine approaches 0 with positive numbers, then the answer is positive infinity. If you say that sine approaches 0 with negative numbers, then I have to use, then the answer would be negative infinity. What would you say? Positive, of course. Everything is positive in the first quadrant. So then the answer here will be positive infinity. If it is positive infinity, you will identify x equals 2 pi as a thank you. Please redo the problems we do in class. Please, I would beg you forever. If it takes forever, I'll beg you forever. It's the only way. Okay, any questions? Any questions? We have not finished 2.3. I still have to talk about a few things in 2.3. And here is, yes, please.
I just have a question in the notes we did last class.
Yes, please.
For the first piecewise define function,
Yes.
we're writing our ordered pairs, and I don't know what was going through my head, but I got tripped up as far as reading it as to do a normal parenthesis and a bracket, and I just want to make sure I get those down right.
From last notes. I still have them if anyone wants them. I brought them for you. As I said, I normally shred them or recycle them. Is it from the last? Oh, this is not yours though. That's what. Very simple. I can go back to the class notes.
Yeah.
It's even easier. I have them, but I don't know what I did with them. They're here on the table. Okay, let's go back. Yes. So when we change this notation in the interval notation, we see the parenthesis.
Right. Yeah.
When we change this into the interval notation, we have the bracket and parenthesis. And when we change this into interval notation, we have the bracket and parenthesis.
Right.
So that's where these symbols come from.
Right.
And then on this interval, we are using this function. So I have it's linear, so I have to have two ordered pairs. I picked -2, and I got -1. And then when you plug in -1, you get 0.
Okay.
Is that okay?
Yes. So that would be in parentheses then, because that's
Yes, because of this symbol.
right. Okay.
Then this symbol has -1 to 1. Right here, -1 bracket 1 parenthesis, -1 bracket for -1 under -1, and then parenthesis under 1.
Okay.
And then from here I have a bracket and parenthesis at the end, which I don't care for. So I have the bracket because of this symbol. It's the bracket under 1.
Gotcha.
Is that better?
Yes, ma'am.
Did I answer your question?
Yeah, you did.
Okay.
Yeah, I just want to make sure I got that organized.
Very good. Good question. Anything else? Yes, please.
When you write the limit of x is approaching a number with a plus, that means does that mean from the left to the right when you like write it out?
So if it's plus, it's with numbers larger than.
So it would be coming this way.
From the right.
From the right.
Yes, yes. With numbers larger than, with numbers larger, plus with numbers larger than that number, and with minus with numbers smaller than it. From the left, in other words. Good. Other questions? Is there anything else you tried? Anything else you would like to see? Anything? Okay, so I'm looking here, and the last problem we looked at was 25 on 107. I think there's just one problem is not enough, so let's choose something else. So we had 25. So I think we should choose at least one other problem from here, and then we'll continue. I have a couple of theorems to discuss with you.
30.
Very good. So 30 is this. It's very similar to this one. We have to rationalize. So I like to show something else. I don't mind doing 30. But since they are so similar, we did 25 last time, you still have to rationalize the numerator. Can we choose something else?
28.
28 is perfect. It's a totally different story. Similar to what we had on that quiz that you will turn in today. So that is 28. 28 on 107. So we have limit as x approaches -4 from the square root of x squared plus 9 and minus 5. Sorry, I'm copying something else. I do that a lot. I'm sorry. I'm going to erase that. Sorry. Limit as h approaches 0 from 3 plus h raised to -1 minus 3 to -1 divided by h. I should make someone responsible for that. I meant to say managing, moving forward, taking care of it, reminding me, hey, you copied something else. Okay, perfect example. Does this resemble anything that we talked about? Can you think of anything? Thank you. Everything is difference quotient. Of course. In this chapter and the next and the next. Yeah. Very good. It is a difference quotient of the function 1 over x plus 3, of course. But let's focus on this. What is the next step? What do I have to do first, please? Any suggestions? Please.
Can you just put the whole thing on top of the denominator? And make
How will I write it?
1 over h, and then like everything on top. So like I mean to get the
You mean this.
exponent on top.
Please say that you mean this.
Yes.
Okay, I completely agree. I cannot take terms from the numerator to the denominator, but I can replace 3 plus h to negative 1 by what it equals to, which is 1 over 3 plus h. And I have no choice. So every time we encounter, let's say, x to negative 1, that means 1 over x. Anything to a negative exponent is 1 over that quantity. Awesome. What will be the next step?
Same denominator.
Awesome. Great job. So this is limit as h approaches 0. This is h over 1. And we need the least common denominator. Excellent. Thank you. What do I do next? What is the least common denominator?
3 plus h times 3.
Very good. It's the product of the two factors. They have nothing in common, and it's the product of the two. Let me show you on the side a little example. 1/2 plus 1/3. Is the least common denominator 3? Is the least common denominator 2?
Yeah.
No, it has to be the product of the two because 2 and 3 have no common factors. Is that clear, everyone? Excellent. Okay, so now we need the adjustments for the top. What is the adjustment needed here? And the answer is 3 plus h was multiplied by 3 to get this. I have to multiply the top by the same thing. 3 was multiplied by 3 plus h. I have to multiply the top by the same thing. Everyone in agreement? Can you follow, please? Okay, so can anyone give us the numerator?
3 minus 3 plus h.
Minus h.
Okay,
Or, yeah,
So,
minus h.
either we put parentheses, which is fine, negative 3 parentheses 3 plus h, or we distribute negative 1 times 3 and negative 1 times h. So, remember, two things have to happen. That's why I asked you if this is the difference quotient, and you did tell me it was a difference quotient. Two things have to happen. What are those two things again?
All terms that h cancel out.
Terms without h have to go away. Are they?
Yes.
Good. And now in the next step, what has to happen?
The h cancel out.
This one, not the final h.
Right.
I'm not saying you said that. I'm just refreshing your memory. So please write 1. If you don't write 1 and you consider 0, then that will be an error. If you don't write 1 but you know what you're doing, it's fine too. Okay, so then this is limit as h approaches 0 from negative 1 over 3 plus h. And please put it in brackets. Before we continue, I want to refresh your memory or remind you about the following. We had a limit of this function. Then we had a limit of this function. Then we have a limit of this function. Then a limit of this function, then a limit of this function. If you drop the limit operator, you're wrong. It makes no sense. This is the final step. This is when I apply the limit operator, and this is where the limit operator goes away. So what I'm saying is, when I take the square root of 9, I'm applying the operator square root to 9, and I do not write this. This is when the limit, the square root operator goes away. And right now, at the very last step, this is when this operator is applied and it goes away. So when age approaches 0, where does this whole thing go? Or what will it approach? That's it. And this is the only time when the limit operator disappears. So please do not drop it along the way, because it will make no sense. So this does not equal this. This does not equal this. This equals the limit of this. Okay, so please remember, take a note, make a note. I know sometimes you want to use a shortcut. Please don't. Do not drop the limit operator. It's like me saying the square root of 9. That's not a good example, because I already explained that only at the end disappears. I'm going to think of a different example, but you understand what I'm saying. So this is the final answer without the limit operator. Okay, can we move on? Okay, let's talk about a theorem. In plain English, the limit of a polynomial as x approaches a, polynomial, is p of a. Again, you can say you are contradicting yourself. You already told us millions of times by now that when x approaches a, x is not a. True. But it happens that for the polynomial, that would be the result anyway. The same thing with the limit of a ratio or a rational function when x approaches a. It is p of a over q of a only if a is in the domain of the rational function, p of x over q of x, the rational function. If a is in the domain, I will do the same thing like I'm doing with polynomials. I'm going to polynomials. Just plug it in. If it's in the domain. If it's not, I can't. This is also true for all the other functions. Radical, trig. True for all other functions. When a is in their what? Very good. We've used this a lot already. We haven't even discussed it, but now I wanted to put it in writing. Final theorem that I would like to present in this section is the following. Imagine that this is a function. Imagine that this is a function. And I have another function squeezed between those two. This is the function that is squeezed, sandwiched between these two. If the limit of this function exists, and the limit of this function exists, and it's the same number, let's say 5, what will be the limit of the sandwiched right here, at this number? What will be the limit of the sandwiched function? The same thing, right? Okay. I like the graph in your book, so I'm just going to show you this, and I'm going to graph it myself as well. So here's the graph. See this function? This is the upper function. This is another function, the lower function. This one is x squared. This one is negative x squared. And there is a red function sandwiched. I don't care what happens here. I don't have what happens here. I'm only interested in what happens at this point. The limit of x squared as x approaches 0 is perfect. The limit of negative x squared as x approaches 0 is, I don't need to know anything about this function. What will be the limit of this function, the red function, as x approaches 0?
0.
Absolutely. It's sandwiched between those two near that point. Again, I don't care what happens beyond that. I'm only interested in a tiny interval around 0. Okay, so let's see how this works. And why do we need this? The theorem is called the squeeze theorem. Some people call it the sandwich theorem. So the squeeze theorem. The squeeze theorem. So we have a function. It doesn't have to be a quadratic at all. So this is g of x. We have another function, f of x. And I have this function, which is h of x. And of course, this is our a. This theorem has two hypotheses. It cannot be applied unless both are fulfilled. The first hypothesis say that h of x is sandwiched between two functions near a. If I can show an upper function and a lower function near a, I can continue. I can move on to the second part of the theorem. So first I have to convince you by finding these two functions. If I can't find these two functions, the whole thing collapses. I can't use it. The second condition is the limit as x approaches a from f of x and the limit of g of x as x approaches a. What do you think? A have to equal, and of course, and be a number. In other words, they have to exist. If the limit is not a number, the limit does not exist. So this is the second hypothesis. Then from here, from 1 and 2, comma, by the squeeze theorem, what do I conclude? From the first and the second hypothesis, by the squeeze theorem, what do you think we conclude? So I'm just going to put a number here like we normally do, L. What will this be?
L.
Indeed. Absolutely. Now the question is, okay, it's an interesting theorem, but why? Why do I need this? And the reason is, in certain situations, we have no technique of finding the limit. Not factoring, not simplifying, not rationalizing, nothing. And this is the only case, the only option we have to determine the limit. The last resource. So here's an example for you. (39) on page 107. We have limit x to the fourth times cosine 2 over x as x approaches 0. We're asked to find this limit. What is the first step?
Plug in 0.
Exactly. Where does this go?
0.
Good. Where does this go? Before you answer, allow me to refresh your memory. I'm gonna do that, and I think we did that last time, but let's do it again. The graph of 1 over x or 2 over x is not gonna be any different. This is the graph of 1 over x. So now I'm going to ask you, before we look at cosine, where does 2 over x go when x approaches 0? From either side. Right. And now I'm going to ask you, how much is cosine of dne? How much?
0.
No idea. I have no idea. So I don't have anything to say other than I'm going to start by discussing cosine 2 over x. And there is something we know about cosine as well as sine. We know that these two functions and no other trig functions, sine and cosine, are bounded. What is the maximum possible value that cosine can have? Very good. What is the minimum possible value that cosine can ever take for any angle you want on the planet? -1, of course. Do we remember this? We don't. Okay. So I'm going to have to digress for a moment. Okay, I'll come back. This is the unit circle. This is the x-axis. This is the y-axis. And here's an angle, central angle. Let's say this angle is alpha. How much is this? From the center to this point, how big is it? How big is the radius? 1. Very good. So let's determine sine alpha. Remember, this point has 2 coordinates. Has this x value, agreed? And it has this y value, agreed? So can anyone dictate sine alpha? Opposite over the hypotenuse. So this piece, the measure of this piece from this point till this point, is nothing else but sine alpha, which means sine is measured on the y-axis. How big can sine be? How small can sine be? That's it. Is that clear? Okay, what is this piece from here till here equal to? Obviously cosine. So then cosine is measured on the good. What is the maximum that cosine be?
-1.
And minimum -1. So that's why cosine of any angle as well as sine of any angle can only be between -1 and 1. Is that okay? Good. So let's come back to our problem. So we are trying to find this limit. I'm trying to build this function. And of course, my hope is that I can squeeze it between 2 functions. And that I have this function in the middle. That's my hope. Ready? So I created this piece. And I know it's bounded by -1 and 1. But I also have this piece to add in. What should I do to all 3 sides in order to have in the middle this function? Multiply all 3 sides by x to the 4th. Multiply all 3 sides by x to the 4th. However, I have to think for a moment. If x to the 4th is positive, the symbols stay the same. Otherwise, they change. If x is 0, I'm not allowed to multiply both sides by x to the fourth. All three sides by x to the fourth. We can multiply by 0. So, is x 0? No, why? Because when we say x approaches 0, we really mean it. X is not 0, correct? Agreed? What about x to the fourth? Is it always positive? If it's always positive, I keep the inequality symbols. If it's negative, I have to switch. Is x to the fourth always positive? It is. So x to the fourth, always positive, never 0. I'm allowed to multiply all three sides. Ready? So let's do that. So then we have negative x to the fourth, cosine 2 over x less than or equal to x to the fourth. And this is my first hypothesis of the squeeze theorem. This is our function that we know nothing about when it comes to the limit. And this is our lower function, which is f of x. And this is our upper function, which is g of x. What do I need to show next? Or do next? I have to find the limits from which functions? Very good. Negative x to the fourth when x approaches 0. And limit of x to the fourth when x approaches 0. What are they? Very good. From 1 and 2. By the squeeze theorem, what do we conclude? That the limit x to the fourth cosine 2 over x as x approaches 0 is very good. Is this clear? Questions? So please remember, cosine is measured on the x-axis. Sine is measured on the y-axis. Sine is standing and cosine is lying down. Is the adjacent and sine is the opposite. Okay, let's look at one more. 38. Same page. We have 2x less than or equal to g of x less than or equal to x to the fourth minus x squared plus 2. It says for all x values. And we're asked to find the limit of f of x as x approaches 4 from either side. I'm waiting for your suggestions. What is given to us, what we are told, what we have to do, anything, please. Please.
Plug in 4 back.
Where? And why?
Well, they all have to be equal to the same thing.
So first of all, this is the first hypothesis that is already given to us. We don't even know anything about the function. I don't even have the function. So I already have f of x, and the other one, let's call it h of x. It doesn't matter. So the first hypothesis is already fulfilled. It's given to us. In the second step, what do I have to calculate? Yes, any questions? What do I have to calculate now? The limit of 2x as x approaches 4. I have to calculate the limit of x to the fourth minus x squared plus 2 as x approaches 4. And if, what? If those limits exist and they're equal, what will I conclude? That the limit of g of x exists and is the same number. So what is the first limit, please? What is the second limit? Was it 4? Did I copy it correctly? Oh yeah, of course. I copied something else. I always do. Please, it's 1. I don't know how I came up with 4. Where the 4 came from, no explanation. So this is 2. Sorry about that. So then, yes. So from 1 and 2, by the squeeze theorem, what do we conclude about the limit as x approaches 1 from g of x? 2. Sorry about that. I don't know where oh, the 4 is right above it. Sorry about that. So x approaches 1, and I read from here, x approaches 4. Sorry. My mistake. Good? Any questions? Please.
From question 38, did you, I just got the one we just did right before this, how you got the other side of it?
You mean this one?
37, yeah. How did you get that?
Cosine is bounded between -1 and 1. So I have 3 sides.
Yeah.
So I multiplied all 3 sides by x to the 4th. So this was the lower function and this was the upper function.
Okay.
Better?
Yes.
Perfect. Great. I would like us to work on a function with absolute value, and only then we can move on. So here are the functions with absolute value. There is one here at the bottom as well. We need to refresh our memory on how to use the absolute value and how to simplify a function with absolute value and then find its limit. So please choose whatever you want, and then we can move on to the next section, unless you have questions for me. Which one?
42, 41. So,
So I think we should also look at one with a fraction. We can do 2, it doesn't matter to me, but I would like to have also a fraction in there. Okay, so we do 44, perfect. And we can do 41 and 44? Is that what we want? Okay, perfect. So 41, 107, and we have limit as x approaches 3 from 2x plus the absolute value of x minus 3. Remember, I always try to give you some point. Some pointers to keep in mind so that you don't make errors. Remember, I always try to connect results or steps, if you want, to what we're working on. And one of them was difference quotient. 2 things have to happen. If they don't happen, I'll cross it out and start from scratch because I know something is wrong. The same thing here. I'm going to give you a pointer, and the pointer is this. I see an absolute value. Every absolute value has 2 options. So I expect to see 2 different things in here because of the absolute value. So the requirement here is simplify the function. Did I copy? Was it from the left or from the right? No, from either side. Simplify the function first. Yes, the limit is very important, but simplifying a function with an absolute value is even more important. So we talked about the absolute value last time, correct? Yes? No. Okay. If we didn't, let me refresh your memory. What are the options for the absolute value of x? Very good. Oops. Only one. You don't have to put it here. You can put it here, but only one time. The equal symbol cannot be in both. Either the first branch or the second branch has the 0. Okay. We understand this definition, correct? Questions? I'm not interested in the absolute value of x. I'm interested in the absolute value of x minus 3. So 5 places where I have to replace x by x minus 3. This place becomes x minus 3. This piece becomes x minus 3. This piece becomes x minus 3. This piece becomes x minus 3. And this piece becomes x minus 3. I'm only mimicking. So please notice 1, 2, 3, 4, 5 identical except the minus here. So I'm going to write it again. I was just making a point. So then the absolute value of x minus 3 is x minus 3 if x minus 3 is greater than or equal to 0. The opposite of x minus 3 if x minus 3 is less than 0. I continue simplifying and solving this inequality. I refuse to solve this one. And please, you should also refuse to solve this one. Because whatever I get here, this must be the opposite. So the absolute value of x minus 3 is then x minus 3 for x greater than or equal to 3, or negative x plus 3 for x less than 3. Resist trying to solve the second inequality. You may come up with something that is wrong. So please keep that in mind. There's no need. If the first one is greater than or equal to 3, the other one has to be less than 3. If this one is less than or equal to negative 5, this must be greater than negative 5. No question. Okay. But this is not what I'm interested in. I'm interested in this. So then, there are 2 options for it. 2x plus the absolute value of x minus 3. One for x greater than or equal to 3, and the other one for x less than 3. Can anyone dictate the 2 possibilities, the 2 options? I have to, yes, but I have to write it. 2x plus x minus 3 is the first option. And the second option? I have to copy 2x. That's we are simplifying this now. So 2x minus x plus 3. And yes, you're way ahead of me. I love that. It is 3x minus 3 for x greater or equal to 3, and it is x plus 3 for x less than 3. Awesome. Now I have to determine the limit as x approaches 3 from the left, and you will tell me from what, and limit as x approaches 3 from the right, and you will tell me from what, because I'm asked to find the limit from either side of 3. So since I have 2 possibilities, I have to determine both and then conclude about the limit from either side. So which branch do I put in here? Yes, x plus 3. Of course, which I'm going to ask again. I know it's silly. Which branch do I put here? Yes. So please give me the answer for the first.
6.
Awesome. Please give me this answer for the other one.
6.
Good. Okay. Finally, what is the answer for this?
2.
If the left limit is 6 and the right limit is 6, this must be 6. If the limit from either side is 6, if the limit from the left-hand limit and the right-hand limit are 6, then the limit from either side has to be 6. Any questions? Please.
Why couldn't you just plug 3 into x in the beginning?
Very good question. Very good question. This will be the requirement. So that's part of the answer. You have to simplify the function first, and you'll see in a minute. This was a very simple example, in which that will work, but not in others. Yeah, very good question. Thank you. You always help me with your questions. I think I mentioned that to you. A couple of semesters ago, a student asked me, what is the difference between this and this? And then I said, whoa, why didn't I ever connect those two topics and talk about them together? So please, ask any question you may have. You make me get better, and I'm sure your understanding gets deeper. Okay, we chose, you said 44, right? Okay, so we have limit as x approaches -2, again from either side, 2 minus the absolute value over 2 plus x. Again, we have to simplify the function first, and we have to start with the absolute value of x. In this case, I don't have to simplify anything or replace. It's x for x greater than or equal to 0, negative x for x less than 0. Therefore, the entire function has two possibilities. Let's write them before we simplify. And please tell me, what would you write? Of course, one will be greater than or equal to 0, and the other one less than 0. And there is a question mark here in a minute. We'll get to it.
2 minus x over 2 plus x.
Very good.
Can we just put the whole thing in parentheses and then
So when you replace this by negative x with minus in front, will be 2 plus x over 2 plus x, right? So that will be the denominator cannot be 0, right? So now we're asked to find the limit from when x approaches -2 from either side. So limit as x approaches -2, which branch? Top or bottom? Exactly.
So just
And who cares that x does not equal -2? So is here. X does not equal -2. So what is the answer? 1. So careful with these absolute value. You have to simplify them. You have to study the function, and then find the limit. Any questions? Yes, please.
to get 1, did you, for the numerator, you just turn it to the addition?
Yes, because I have minus in front, and this is negative x. Negative x will be 2 plus x over 2 plus x, which is 1.
Gotcha.
But only if x does not equal -2.
Okay.
And I cannot put -2 here because it's not a number greater than or equal to 0, and I have to include it here because that's where it is. So that's why I use this branch and not that branch. Because that's where -2 is, to the left-hand side of 0. And that's why I have to use this. Any questions? Any questions?
Oh, so you don't do the left and the right because it doesn't equal -2? Is that what you're saying?
Right. So in this case, since it's 1, even if I try to find the limit from the left or from the right, they will both be 1.
Gotcha. All right.
But yes, otherwise I would have. If they had x in them, I would have shown the calculation for both. But
Okay.
since it's a number,
Since it's a number,
yes,
okay.
you're correct. Yes.
Okay.
Do you think we need another example like this? Yes?
Can we do
Becca.
43?
Yes, let's do 43. In 43, we have limit. As x approaches 1/2 from the left, from 2x minus 1 over the absolute value of 2x cubed minus x squared. Perfect. This is another